I think that OpenTelemetry growing to be the second biggest project on the SynSafe landscape happened for a reason.
This is DevOps Paradox, episode number 279, Exploring Grafana Alloy. Welcome to DevOps Paradox. This is a podcast about random stuff in which we, Darren and Victor, pretend we know what we're talking about. Most of the time, we mask our ignorance by putting the word DevOps everywhere we can and mix it with random buzzwords like Kubernetes, serverless, CI/CD, team productivity, islands of happiness, and other fancy expressions that make us sound like we know what we're doing. Occasionally, we invite guests who do know something, but we do not do that often since they might make us look incompetent. The truth is out there, and there is no way we are going to find it. P.S. It's Darren reading this text and feeling embarrassed that Victor made me do it. Here are your hosts, Darren Pope and Victor Farson. We're heading into the fall now in 2024. AI is still AI. But one thing that just keeps poking its head back up over and over again is OpenTelemetry. How much are you working with OpenTelemetry now, Victor?
Depends. Working as if coding, I don't know, OpenTelemetry agents, close to zero, none. By using, it's all there is to it today, right? I mean, nobody's using anything that is not OpenTelemetry anymore and lives in the same century as I do.
On today's show, we have Paschalis on from Grafana. Paschalis, how you doing?
Doing well today. How about you?
Good. Pronounce your name correctly because everybody knows I have a hard time with names, but this is you are actually our first Greek guest.
That we know of.
That we know of.
Yeah.
I'm having a really hard time. So pronounce it in all the beauty and glory that a Greek person can pronounce.
You did a great job, though. It's Paschalis.
By the way, those two sounded completely different to me. So I'm confused that you said that he did a great job. He didn't.
You're being very gracious. I appreciate it. So Paschalis works on Alloy, which is from Grafana. It was announced at GrafanaCon in 2024. And it's a distribution of the OpenTelemetry collector. But, dun dun dun, a lot more. How did this even come about?
Well, I think that it was a culmination of many factors. It's the spiritual successor to Grafana Agent. So if anybody has been using Grafana Agent or more specifically Grafana Agent Flow, they're going to feel right at home. But it was also the culmination of our continuous investment in the OpenTelemetry ecosystem and all the lessons learned from years of running telemetry collectors at scale, both dogfooding inside of Grafana and from all the stories from our customers and people that we have helped set up their own infrastructure with.
It was the spiritual successor, if you will. Before we go down more Alloy stuff, is it strange to you that all of the companies, I'm going to sort of say the competitors in your space, and I'll say their names, like the Datadogs, the New Relics, who do I not want to leave out there? Dynatrace. Thank you. Yeah.
Splunk.
So I'm not trying to forget anybody. Is it surprising to you that everybody has sort of collected around OpenTelemetry?
No, I think that it's been like the direction that everybody is wanting to go towards, and everybody's been riding this wave. The promise of OpenTelemetry of making observability something that is vendor neutral and interchangeable and allows everybody to compete on the same playing field, it's something that really intrigues people and people really want to see this succeed. So I think that it's an obvious play for all these companies to try and ride this wave and go along with the times and see where this journey takes everybody. And I think that OpenTelemetry growing to be the second biggest project on the SynSafe landscape happened for a reason.
Doesn't that at the same time remove competitive advantage? Because usually, standards of some sorts tend to be very interesting for smaller players and actually damaging for bigger players who already have their own solutions that are competing with those standards and have to rewrite millions of lines of code, blah, 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 blah.
Yeah, that's true. But it's interesting seeing that basically it's also the big companies pushing for OpenTelemetry. It's not the other way around. I don't know. It's still early. The scope is really, really big for what OpenTelemetry is trying to achieve because it's not like tied to just the collectors, but it's also like semantic conventions and SDKs and even LLMs to ride another like trend there. So there's a lot of room to innovate and to do things differently, I believe. It's going to be an interesting couple of years to see how all this evolves in the industry.
Why did you decide to actually create Alloy? What was the business purpose behind it? And other than, now, Alloy is fully open source.
Exactly, yeah.
It's just a bundling of all of these top projects into one Uber project, correct?
Yeah, I think that's a fair assessment. So to make the decisions behind it clearer, we can go through like a small history of how it all evolved as a project. So Grafana Agent started off as a Prometheus Lite mode, like Prometheus without the TSDB, to be able to have a smaller footprint for a telemetry collection at the edge, right? So that you could say that I can install Prometheus in all of my machines and have it scrape metrics locally or from neighboring applications and send them over instead of having to manage huge Prometheus. But then we actually started like implementing logs by adding prompt tail and traces by adding OpenTelemetry collector components. And this all started feeling like a mishmash of different products and didn't feel like a cohesive user experience. So the first goal for us was to bring all of these under one tent and provide a good cohesive user experience for people who wanted like both Prometheus metrics and Loki logs and OpenTelemetry metrics, logs, and traces into one package. So I think that we're one of the only OpenTelemetry collectors out there who have this really, really good interoperability within the Prometheus and Loki ecosystems as well. And it allows people to adopt OpenTelemetry at their own pace. So if you're already having a setup that's based around Prometheus, you can use Alloy to gradually start playing around with OpenTelemetry and integrating more and more of your services instead of having to do this big bang transition. Another characteristic of Alloy that we really want to double on was this modular component-based architecture. In contrast with Grafana Agent, Alloy has this notion of components that are tied together to form pipelines, with each component having its own inputs, outputs, health information, debug information, its own built-in UI, and it makes the debugging experience much, much easier for people to be able to poke around their agent and see exactly what's going wrong in each part of their pipeline. To continue with the OpenTelemetry discussion that we started off, it was like a given for us that we'd like to support OpenTelemetry as much as possible. So we're using the same battle-tested code that OpenTelemetry does, the same components, to be able to provide this source of experience for people who might be already using the collector or who want to start dabbling in the OpenTelemetry ecosystem.
So it's a tool that I can use if I'm using any of those items that are in Alloy, drop in Alloy, and then I can start using the other things without having to rechange my stack all over again.
Yeah, that's ideally the goal. So for example, if you're already using like Prometheus to scrape things, we have automated config converters that can get you to using Alloy within a minute or two. Same if you're using the OpenTelemetry collector and you want to take advantage of some unique characteristic of Alloy, there's automated config converters so that you can use your OpenTelemetry collector config file as well and then start pointing at the different bits and pieces that Alloy features, like getting secret from HashiCorp Vault or our clustering implementation and so on and so on.
Why did you decide to make it open source? Why didn't you just say, we're just going to run it as a service?
I think that it was a given decision. We never actually considered making it closed source. I think that a lot of people inside of Grafana like to say that OSS is in our DNA, and the fact that it was also like the spiritual successor for the Grafana Agent project, I think it made it a given decision. It didn't need like much conversation. And it also allows us to give back to the community as much as possible instead of just keeping that for ourselves.
So when this was announced, and since that time, what has the uptake been on people using Alloy? Has it been, okay, or what's been the feedback from the community?
The feedback that I've got from both the community and customers is that they really like the interoperability that we provide with their existing infrastructure setups. So they can really easily put it in their stacks and continue working with Prometheus and use our conversion layers to start doubling into OpenTelemetry or vice versa. People also really like the built-in UI that helps them see what's happening in a glance. The configuration syntax that's based around expressions also provides some kind of dynamism to the users so that they can use configuration to enable novel use cases for them. One of the things that I think has been the most interesting for users is the ability to share pipelines, share configuration with the entire community throughout your organization. The concept of modules around Alloy that allow you to reuse configuration in a GitOps approach, I think that's been one of the keystone characteristics that people keep asking on and on about.
What is a GitOps approach in the context of Alloy?
You can use the import.git configuration block in Alloy to fetch configuration from a Git repo and build custom components for yourself. So if you're a large organization and you want to standardize the way that your logs are processed, you can have Alloy reach out to a centralized Git repo and fetch a custom components that defines all the rules that you want your logs to pass through without having to go through your thousands of agents and fine-tuning each of those and have the risk of forgetting to update some or having some updates fall through the cracks.
Okay, so it's looking at the Git repository and synchronizing whatever is in Git when configuration is concerned. So the next time I change the configuration, I just push it to Git and Alloy will a minute later update itself, something like that.
Exactly, yeah.
Okay.
So if you have strict concerns around compliance, or if you want to have some kind of standardization around your entire fleet of alloys, it's a very powerful approach.
And those are Kubernetes controllers, I guess, CRDs and all that stuff, right? In case you're running it in Kubernetes. So I could synchronize it with Argo CD or Flux or whatever else I might be using, speaking of GitOps, right?
Right now, you can load modules through Git, through an HTTP endpoint, through a file, or through a string. So if your existing pipeline can upload something to Git, then you should be good to go. In a Kubernetes environment, you could also utilize some components to sync information from CRDs. So Alloy gives you the power to synchronize Loki or memory recording rules via Kubernetes CRDs, which are also a recent trend. And we're looking to expand on this also in the future.
But right now, there is no operator, right, with CRDs for Alloy itself. It's a universal YAML, not Kubernetes specific, right?
Yeah, we purposefully moved away from an operator deployment model because we thought that this extra step of abstraction was hard for users to follow and it required a lot of prerequisite reading. But we do have components to read from Prometheus operator CRDs to do the same thing. So if you're already using Prometheus operator service monitors or pod monitors, there's an Alloy component to automatically scrape those and get the same result.
So I'm assuming you weren't born into Grafana. What was your path like to get to Grafana?
Probably a typical path. I'm not a software engineer by education. I studied physics. Then my first tech job was in a startup optimizing retail supply chains. Then worked in the ride-hailing industry for a couple of years. After that, where COVID was a massive hit in the ride-hailing industry with all the lockdowns, then came the story of Grafana.
Retail supply chain feels very similar to what's happening inside Alloy. It feels like a digital twin to retail.
I'd love to say that's true, but that job was super more strict and corporate and suit-looking types, transferring information around in Excel sheets. Not that I have anything against that type of environment, but it was a lot more locked down and different in structure.
Environmentally, yes, but the actual work feels like, okay, retail supply chain, I've got to get from the vendors, get it to my distribution center, and then out to my store. That feels very much like Prometheus going through a pipeline to get into into whatever store I'm going to use.
Yeah, that's true, I guess. That's a good analog there.
Why do you find this so interesting? Because you're collecting data and you're creating reports. It's, again, you just said it sort of. This is nothing but a fancy Excel spreadsheet at the end of the day.
Yeah, that's true. I think part of the fun is seeing what crazy things people do with this data. And I think that is also, I'd guess that is also what engineers working at other competitors would say. Like seeing your data be used for like Formula One teams and the rocket launches, people monitoring their home brewed beer, or people keeping track of their glucose level so that they're more healthy. All the crazy things that people do using this observability and Grafana is also a reason to keep on doing that and figuring out solutions to give out to those people. I don't know if you two have used Grafana and any other observability vendor in your daily lives to improve something.
Less to improve, right? More to discover, to get basically to me the definition of observability tools is that they're causing me depression. I find out things I don't want to find out.
Yeah. That's too bad. But for example, like in GrafanaCon, we also had like the Golden Grot Awards for the best dashboard. And there was this guy who built a dashboard to find out what's the best way to commute from his house to his work. So he pulled data from the local weather station, how often the trains run, what's the probability of getting stuck in traffic, and he would make decisions on how to get to the office in the best way. And I was like, okay, that's crazy.
That's a proof that he has a really long commute, so he has too much available time.
So I'm sitting here thinking about Victor's angle of just tell me what's wrong, to some of the crazy ideas of how to best get to work or watching my beer brew. How do people come up with these ideas? It seems like to me, I think like Victor. It's like, I need something to track what's going to go wrong. Not if something's going to go wrong, when it's going to go wrong. I need to know, what's been the trend up to that point. But it seems like the other way is I'm trying to solve a problem. It's a very interesting, sure, I've thought about it, but it's like I hadn't really thought about it, if that makes sense.
Yeah, it's kind of interesting, this dualism. Like, I think that it's a balance between trying to see what's wrong with an existing system and then finding new ways to explore the system's behavior and then doing more work into patching all these holes and then making sure that it doesn't go bad again. So I think that this exploratory work is also interesting when you're trying to understand what's really going on inside of your infrastructure. For me, it is something that is interesting to do, and that the people will really gain something from that approach instead of just using some pre-made dashboards, some pre-made alerts to page them up in the middle of the night. I think that this preemptive exploration and understanding of the system is super crucial. I recognize that it's hard to do. It might require like some pre-existing knowledge of, say, PromQL and how to build dashboards and all that. But I think that's why the direction of the industry is to also make these sort of experiences easier for end users so that you don't have to be like a logQL expert to figure out anomalies in the logs in your Kubernetes cluster, or you don't have to be like an expert to write some smart alerts to measure your SLAs. I think that this sort of tooling that can make people's lives easier in sort of exploring their infrastructure is going to help people a lot.
Do a lot of people have the same problems? Let's stick on Victor's side for just a minute of solving the problem. They drop in Alloy, you've got company A, B, and C, and they're shipping their data. Do people think they have the same problems? Do we just have a communication problem as humans? Because it seems like we should be able to get to the point to where if company A is having this problem, company B, if they're running the same stack, is probably going to have the same problem. How can we communicate those things better?
From what I've seen, largely, yeah. Like if you're running a similar stack, then odds are that the same set of alerts could benefit both company A and company B. But in my experience, it's not always the exact same thing. I haven't worked in many different jobs to see their different infrastructure setups. And in my tech jobs, it's been like no infrastructure setup, some infrastructure setup, and Today it's like 100% monitor everything and dog food with all your heart. So I'm not sure what goes on out there in the industry. I'd love to hear your take on it. I think that there's always these small differences from decision, from craft, from a previous system that's come and went. So you need to somehow be able to easily fine tune all this pre existing infrastructure just for your use case.
I imagine, and this is not backed by any data, so I cannot confirm. It's more like a feeling that dashboards tend to be very similar between companies, and then alerts differ more, right? Because this is when I want to find out that something is wrong, be alerted. But once I find out that there is something wrong specific to my Kubernetes setup, I will probably go to a similar dashboard like another company is going, because how many ways there are to show this memory and CPU usage of something, right?
And I think that also ties to our previous conversation around OpenTelemetry, that semantic conventions can be really helpful in standardizing these sort of alerts as well, so that you know that the data is going to be present around how to alert on a certain behavior, or how to be able to get this information automatically from my applications and not have to monitor everything by hand. Do you think that's going to be something that OpenTelemetry can help with?
Here's a question, actually, something that is bugging me. I fully understand the value of OpenTelemetry for when I'm instrumenting my own code, right? So I'm adding metrics to my application of traces or logs, and that's an investment. So I want to, I will have to add some stuff to my code, and I want to make that investment in a way that is not dependent on a specific solution, right? On a specific vendor or whatever, because I'm never going to rewrite that code. So to me, that's a very, very clear win for OpenTelemetry, right? But then as an end user, not as a vendor, how much do I or should I care what is the format of third-party collectors, right? So something is collecting. So for example, Prometheus, right? How much would the user care that Prometheus is fetching not OpenTelemetry or OpenTelemetry, right? How much of a difference it is for third parties?
I think ideally it doesn't make much of a difference. Then users shouldn't have to worry about it. That's also part of why Alloy's interoperability was put in place. The thing is that I believe that OpenTelemetry semantic conventions are going to make the telemetry itself a little bit more predictable. That's the benefit that I'm seeing there.
I want to maybe go after the elephant in the room. If I'm running Alloy, how much storage space am I going to need? Because I think about, I'm sending out streaming data all the time. Metrics, logs, traces, you name it. It's just pumping out.
Yeah.
And I'm deciding to run it locally. What should I expect to need? Because I want to use those pretty dashboards, those pretty uber fancy Excel spreadsheets to be able to see how to get to work.
From Alloy's side, the only storage space you'll need is probably if you're running with a Prometheus write-ahead log. So Alloy itself shouldn't need like storage space in many other use cases. Or you might need some local storage to store like your positions file, the offset that you've read from a log file, so that you don't keep up rereading the same logs over and over again. It's entirely possible to use Alloy without ever touching local storage, so that you buffer your telemetry in memory and you keep on retrying to send it to the backend of your choice. Any OpenTelemetry compatible backend.
So that scares me. I mean, yes, that's great. I can just use all in memory, but I lose that collector and it's goodbye the data that didn't flush yet.
So you could either use the Prometheus write-ahead log implementation that allows you to continue retrying to send data whenever there's a network outage, or you could use OpenTelemetry's I'm not the OpenTelemetry exporters implementation. I'm not sure what it's called though right now to do the same thing.
How much does it matter, Darin, if you lose data? I'm talking now about metrics, right? I know for logs, right? But metrics are aggregated. If you lose a minute, would you even notice?
Minute, I'm not too concerned about. If it's 30 minutes, I'm concerned.
Sure.
So I guess that leads me to the point. Can I run Alloy in some sort of HA configuration?
Yeah, and there's a bunch of different ways to go about it. You can use the Prometheus way of doing things with hash mode sharding, since the Prometheus component do support the same ideas that came from Prometheus. But we've been working on a clustering implementation that tries to abstract away all these questions about how do I scale my collectors and how do I provide high availability for my collectors, that hopefully can answer these questions. Granted, it's still in a bit early phases and only works for the pool model right now. So it allows you to distribute targets intelligently between Alloy nodes and assign responsibility for scraping them on different nodes. So if somebody goes down, then the targets are automatically reassigned to the rest of the cluster. But we're looking to expand on this and make it the de facto way so that you only have one answer to the question, how do I scale my Alloy? Or what do I need to do to make sure that I don't lose data when Alloy goes down?
The scraping side is interesting because that needs to be scheduled somewhere to do the scrape. I'm thinking, and that's good, right? That would have to be handled at that layer. But I'm thinking from just an OpenTelemetry perspective, I'm instrumenting my code. Then, if I don't have a single endpoint today, I could do a wrapper around OpenTelemetry and just send it to, hey, are you awake? Right? If I didn't get back a 200, then I'd just go ahead and send it off to another one, right? And let those kinds of things just automatically happen.
You mean if the backend database didn't respond with 200?
If the place I'm sending my OpenTelemetry data to didn't respond with a 200, then I could fail over to another Alloy instance that's available. Test if it's available and right or something. I'm just thinking until the perfect world HA solution exists, I could do at least the OpenTelemetry side of things by doing effectively a round robin.
Yeah. That's pretty similar to what the scaling recommendation for OpenTelemetry collectors is, which also applies to Alloy, which is to have like this two-tiered layer of collectors. One that intercepts all these requests and then uses the hash of a resource to forward to the second tier of collectors that then does the bulk of processing, so that you always have one layer that's simplified and dumbed down to intercepting data and then routing it to the correct collector. That also applies to Alloy, and if we could simplify that to something that is even easier for users to use, then I think that idea could play really well, yeah.
What is on the roadmap for Alloy?
That's interesting. That's an interesting question. To be honest, a lot of things. The way that the Alloy is built out is more like a platform for people to do things. Like, it's very easy to add new components, to import new components from the OpenTelemetry collector. The configuration syntax makes it easy to enable novel use cases and connect components in ways that we didn't anticipate, so that you can do more advanced telemetry. So if I had to guess, it would be getting some more powerful configuration syntax so that you could use like conditionals and loops in your Alloy configuration to make it easier for people to express what their configuration needs are. Expanding on more components to make it easy for you to get data in and out of Alloy. So we already have like 2 or 3 dozens of components that allow you to use bundled in exporters to get data from major cloud providers, most popular applications and databases, and we're looking to expand on that. And I think that getting an even stronger story around how to do clustering and expand that to the push model so that you can, again, use a similar approach for scaling both Prometheus-based and OpenTelemetry-based workloads would be our top priorities. But again, this is not like only a Grafana-led initiative. We try to make this into a community-made initiative. So We routinely have ideas thrown in from the community, people coming in with PRs of their own, and we'd love to hear what the community has to say on this roadmap.
Can you think of one of those PRs that's come in from the community that everybody looked at it and went, why didn't we think of that?
I'm trying to remember if it was a community PR or not, but somebody wanted to provide a component to sync Loki recording rules and memory recording rules from CRDs, which was at that moment like a great idea, being able to use Alloy as the endpoint to configuring more things. And I think that has a lot of benefit for the future. What if you could say configure your dashboards via CRDs or use CRDs from other places like your Valero CRDs to do something interesting with Alloy? That was an idea that was really interesting. The standard library of Alloy has had many community contributions around people wanting an easier way to use their configuration file to get information from other systems and then apply it on their telemetry, stuff like that.
So I'm looking at a picture. People listening can't see this, but Alloy's in the middle. To the left-hand side of Alloy is I'm either receiving data coming in from apps or I'm scraping data back towards apps. That makes sense. So I'm getting data into Alloy. And then out of the other side, thinking a distribution center. So I've got my data coming in. I'm either unloading the trailer or somebody's in the trailer pushing stuff into the distribution center. And then on the other side of the distribution center, I've got telemetry data going out, but I've also got alerting rules. So the telemetry data makes total sense, right? I've got on one side, I'm either receiving pulls or receiving pushes. I can't receive a pull. I'm either pulling it or I'm getting get it pushed to me. And on the other side, everything's going out to a landing store, wherever that may be, database, whatever. But why did the team decide to put the alerting rules into Alloy as well?
No, alerting rules aren't defined in Alloy right now. They could in the future. That's an idea. But Alloy is able to sync these rules that it discovers from Kubernetes back to the database.
Okay, then I guess I just misunderstood the picture. That's fine.
Did that make more sense, though?
It does make more sense.
Yeah.
I'm just trying to think. I'm looking at Alloy, and it's basically just, again, I'm going to use the distribution center model here. It's just stuff's coming in on the left, going out on the right, but it's got everything in it. I guess that's the key point, to where I could build this myself. In fact, you built it yourself using all the different tools, aggregated them together in order to simplify that problem.
Yeah, and it's exactly the idea around OpenTelemetry collector distributions. We're using the same underlying code, but we're simply trying to provide even more functionality available to you so that you can have an easier time setting up your observability infrastructure.
Does that hint at potential problem of having to combine too many tools for observability?
I think that there is like a potential danger for that, but this was also the case with Grafana agent, right? Like embedding OpenTelemetry collector component for traces, but also trying to do logs with OTel and metrics with Prometheus. I think that it's always going to be a source of difficulty there, but if this difficulty is hidden away from the user, is abstracted away from the user, and the user has this intuitive syntax of building pipelines and seeing data flow through, and we get to deal with how this interoperability plays out, I think that's for the best to make this tool useful, generally useful for people. Is that what you meant?
No, I was meaning more that I feel that in general in industry we are going in circles most of the time. And, in the past it was, okay, you can use one tool for all your observability needs. Then we said, okay, having one tool means that it's inefficient at everything. Let's break it up into smaller ones, and we have this for metrics, that for logs, this for traces. But now we're having problem that we are having. In the past we had too few, now we have too many. Okay, how can we combine all those that we can configure them as if it's one tool? That feels like we are going back towards to the same point in a circle in a way, right? It's too few or too many, right?
I think that we have a few of these cycles in tech, and I think that's probably going to be true in the future. So we'll see where the direction goes. there's like this trend of having agentless telemetry where applications send their telemetry data directly to the backend, right? This was also a trend in the past, and this has started coming up again with all its benefits and drawbacks. I don't think that there's ever going to be like a one solution fits all thing, but the closer that we can get to solving people's real problems, I think that's for the best.
So if people want to start working with Alloy, what is the best way to do that? Download a tarball, install it? What do they do?
I think the best way is just go in our documentation. We have some great getting started guides, depending on where they are on their journey. If they just want to try it out in their local machines, if they want to install it in a Kubernetes cluster, we have like a guide for getting started with our Helm chart. If they're already using Grafana Agent or the OpenTelemetry collector, we have a migration guide for them to try it out in parallel. So I think the docs are a pretty good starting point for all things Alloy. We're making a conscious effort to make it a strong point of our ecosystem. And also we have an Alloy channel in our community Slack for a more synchronous conversation in case somebody wants that. And our open source repo issues are also open for everyone. So just come say hi.
So let me ask a concrete question of how I might do this. So let's say I am brewing kombucha at home. I don't drink beer, but I'll drink kombucha. What would I do? What's the without me going to look at the docs right now?
Yeah. So how do you get the data out? Do you have like a sensor that's hooked up into a Raspberry Pi?
I've got sensors hooked up to everything. Yeah. I've got all the sensors and I'm collecting, I've got the data. I just need to get the data somewhere else.
Yeah. I think you just go into the Alloy docs and look up in the tutorial of how to start collecting Prometheus metrics. So you just point the Prometheus scrape component to your existing metrics collection and remote write to your database. And that should be it.
Looking at the configuration, as you were talking, it's all YAML.
It's not YAML, it's HCL.
It's HCL inspired, yeah. So Alloy uses its own configuration syntax. I know this may sound a bit scary, but anybody who's ever looked at HCL should feel right at home. We found that it's a small learning curve, but people really like the expressiveness that it provides. And it's much harder to mess up due to a silly indentation error. It's much clearer to define the relationship between components. So all in all, I think that it's going to be an easier way of configuring something for somebody who's never seen a telemetry pipeline before than writing a YAML file correctly.
Out of curiosity, what is the problem that you encountered and said, okay, so we need our own language because this cannot be done, or this is too difficult to be done in whichever other, YAML, JSON, JSONnet, HCL, blah, blah, blah. So what was the thing that sparked a language?
So the thing that sparked the language creation process was the concept of expressions. So how do I do math to assign a new label to some telemetry data going in? How do I have a standard library to decode a JSON file and get a key from that? How do I use an environment variable? For most of these purposes, HCL was fine. Basically, Alloy's configuration syntax was first based on HCL. But the fact that HCL uses its own type system made it too slow for the continuous reevaluation. So, for example, whenever a discovery component discovers new targets and propagates them downstream to other components for relabeling or for scraping them, HCL was too slow for our purposes because it was meant for another thing, right? So we kept all the good things that we liked around HCL, the ability to create like these standalone blocks and the ability to use expressions to dynamically set all these values and combine these components, but basically wrote our own wrapper around it. How did the syntax look to you, by the way, when you played around with it?
I mean, it looks like HCL, right? So very, very similar. But is there a language server?
Not yet, but it's something that a couple of the team members are looking at. We do have some like editor highlighting support and some tooling that we're building to make it easier to get started, like some auto-completion. But the fully fledged language server support, not yet, at least.
I feel like a doofus, but that's sort of my normal state. I was looking at the tutorial section, and of course I didn't read it. I just went straight to, hey, there's code there on the screen. And the tutorials require Docker Compose. And the YAML I saw was the Docker Compose file. But you can run Alloy just as a binary, which puts me in my happy place, if I can, right?
Yeah, of course.
Because, again, if I'm brewing kombucha at home, I probably don't need a rack of servers or even Docker to, start
or you
collecting that
don't
data
need
off.
a Helm chart as well, so yeah.
Yeah, fair enough. So one other thing that's getting ready to come up, again, when this episode releases, it's September 4th, Observability Con is scheduled for September 24th and 25th in New York City. They're going to be talking about, they, being Grafana, is going to be talking about all their latest stack updates. LGTM, is LGTM really just looks good to me? Stack updates, or really?
No, I have no idea what's going on with Observability Con, to be honest. I haven't followed that.
Okay.
I hope that when this episode comes out, we'll have more concrete information. There is going to be a lot of cool stuff shown around there, but I don't have any specific updates around the LGTM stack or other projects.
Hint, hint, we're recording this early, so that's the reason why he doesn't know what's going on yet. But really, LGTM, it really does mean looks good to me.
Yeah.
That's so weird. I'm sorry. It doesn't make any sense. Why would you do that? That naming feels strange to me.
I think a bit of a fun. So if you have Pyroscope as well, it looks pretty good to me. But when you add all these other products, and it starts to break down as a paradigm.
Wait, so you're saying we're supposed to have fun as we work?
Of
I don't
course.
understand that. Okay.
I think that if you're not having fun, you're in the wrong job, right?
I think we talked for almost 50 minutes, and we got to that one line. If you're not having fun, I don't even remember what you said. It's already gone past me. Just rewind a little bit and hear him say it again.
I'm not sure how I put it, but I think that if you're not having fun, you're probably in the wrong place, in the wrong job.
Scraping data makes you happy.
And the fact that you can find ways to do it more efficiently and in a smarter way and solve real people's problems, so that's an added bonus as well.
With strange use cases.
Yeah.
F1, rockets, brewing beer, and tracking glucose. Seems like a very, very interesting way to spend your day-to-day programming life.
That's true.
So all of Paschalis' information is going to be down in the episode description. Paschalis, thanks for being with us today.
Thank you for hosting me today here. It was a great experience, and I'll see you around.
We hope this episode was helpful to you. If you want to discuss it or ask a question, please reach out to us. Our contact information and a link to the Slack workspace are at devopsparadox.com/contact. If you subscribe through Apple Podcast, be sure to leave us a review there. That helps other people discover this podcast. Go sign up right now at devopsparadox.com to receive an email whenever we drop the latest episode. Thank you for listening to DevOps Paradox.